Alright, here's your first video of 2015. I hope you had a lovely break, and I hope all your dreams came true. So here we go. Let's begin with the first of our many problems that we're going to discuss today. Remember that the main thing that we're going over today is, let me turn my pen on, is 6.1, which was solved by graphing, 6.2, which was solved by substitution, and 6.3, which is solved by elimination. Alright, we went over those today. Hopefully you're not having a problem. Let's go over this error analysis. I got 3 error analysis problems that I want to cover with you. And basically it's just describe and correct the error at the right in finding the solution of the following system. So here we have our system, and let's look at what they did. Okay, so up here it basically looks like they are, whoops, that's off just a little bit. Okay. Up here in step 1, it looks like they're solving for x. Okay, they move 8y over. It should become negative, and it does. That's all working out fine. Then in step 2, they take what is x, 21 minus 8y, and they plug it in to what? Can anybody see what the problem is with the second step? The second step has a very big problem. Hopefully everybody sees that what they should have plugged it into, the 21 minus 8y, should be in the other equation. So it should be 7 times that plus 5y equals 14. They plugged it into the same equation. That's a big no-no. You can't do that on substitution. You have to plug it into the other equation. That's why we get that 7 times x. Stop! Plug in whatever x is. We figured it out. It's 21 plus minus 8y. And then solve. Okay? Alright, so there's one. Let's try the other one. I'm going to give you 1 minute. Pause the video. Get this figured out. And then I'm going to start. Okay, hopefully you had a chance to look at that. This is relatively an easy one too. Student graphs the systems of equations. Y equals negative x plus 3. Again, y equals negative x plus 3. Hopefully you were able to identify both the slope and the y-intercept on that one. You guys did really good on that today in class. The other one is y equals negative 2x minus 1. Now, the problem here with this problem is not necessarily the graphs. The graphs are correct. Both the graphs for both lines are correct. The problem is, he concludes there's no solution, when we can clearly see that those are not parallel lines. The only way you have no solution is if they're parallel lines. Those lines are going to come together. They're not going to come together on that graph, but they are going to come together. So you would need to go ahead and find the solution to that. Let's look at another one. Again, go ahead and pause this for a quick second, and then hit resume. Now, if you look at this, the problem here, we're using elimination. So again, you can see that our equal signs are lined up, our y's are lined up, our x's are lined up. Everything that we want to line up is lined up. Then they multiply the top by 4 and the bottom by 3. So we end up with these 12 should be disappearing. And that's what he does here. It says, yeah, they should disappear, or she, whoever's working on this problem. But the problem is, positive 12 plus positive 12 is 24y. The mistake was right here. Remember, we need them to be opposites. One of these has to be negative. One of them has to be negative so that we get a negative number. Okay? So let's try setting up some of these now that we kind of got a refresher on what our 3 solving methods are. Okay, so student statistics. The number of right-handed students in a mathematics class is 9 times the number of left-handed students. So if we read that sentence right there, we have that the number of right-handed students is 9 times the number of left-handed students. So if we let R be right-handed students, and we let L be left-handed students, okay? How many right-handed students are in the class? How many left-handed students are in the class? So these two questions right here, because they're asking about right-handed and left-handed, tell us those are going to be the variables, and we have those set up. We know that there's a total number of 30 kids in the class, so the number of right-handed students plus the number of left-handed students should equal 30. And our other equation is right here underlined. Right-handed students in a mathematics class is 9 times the number of left-handed students. So right-handed students is 9 times the number of left-handed students. Okay? These are our two equations. What's the easiest way to solve these? I already got a variable solved for, so solve away. And here should be your answer. Again, pretty straightforward. I got my two equations, solve for r, so I plugged r into the other one. I did that right here, 9l plus l equals 30. And I found out that there's 3 left-handed students. Then I just take that, plug it in, find out there's 27. The key is just finding what your variables are and setting up your equations. Let's look at another one. A plant nursery is growing a tree that is 3 feet tall and grows at an average rate of 1 foot per year. Another tree at a nursery is 4 feet tall and grows at an average rate of 0.5 feet per year, or a half foot per year. After how many years will the trees be the same height? So it's asking about years. Alright, so one of our variables, let's just let it be y for, and let's actually call this the number of years. Number of years. Okay, after how many years, that's where I got that one from, will the trees be the same height? So I want them to be the same height, so we'll just let h be the height of the trees, really. Now our two equations. We have one tree, okay, so we want the height of that tree. So the height is going to equal, it's 3 feet tall, okay, it is 3 feet tall, and it grows at 1 foot per year. So plus 1 foot per year. For every year, I'm going to multiply by 1, and that's what I get. So 2 years, it'll grow 2 feet. 3 years, 3 feet, okay, and so on and so forth. Another tree at the nursery is 4 feet tall, okay, so it's 4 feet tall, and it grows at an average height of a half a foot per year. So 1/2 of a foot per year, okay, and that's going to be its height. Now go ahead and solve this one. So you can see right here that the answer is y equals 2. Again, both h's were solved. I just set them equal to each other, worked out, and found out that after 2 years they're going to be equal to each other. That is the solution here. Remember, it doesn't say what is the height. It just says after how many years will the trees be at the same height. Okay? So 2 years is your solution.